Now, let's move one step further to understand the mass and relative mass, as well as molar mass. Okay, so we will try to understand each of these terms one by one. Now, let's start with a new page. Imagine if you have one carbon atom, just one and only. Okay, the one and only. So this carbon atom, if you look up to the data book, relative atomic mass of carbon is 12. Alright, so now assume that I have the ability to put together a lot of carbon atoms. Okay, I can't draw so many, so I'll just assume that I have the ability, and I've drawn 6.02 times 10 power 23 pieces of carbon. And if I could put them on a scale, the scale will show up the reading of 12 gram. So this amount, 6.02 times 10 power 23, is what we call 1 mole of amount. So the short conclusion is 1 carbon is only 12. This is just a scale, that's why it doesn't have any units. So if you have 1 mole of this, okay, which is in fact the total number is 6.02 times 10 power 23. If you have so much of this, and if you put on the scale machine, and it will show 12 gram. Alright, so this is what we call molar mass. See, molar mass is simply relative atomic mass with units. Okay, this unit is what we call 12 gram per mole, because the keyword here tells us the unit. Is it 1 mole will have 12 gram, so isn't it 12 gram per mole? Alright, it's 12 gram per mole. 1 mole of this, you have 12 gram. So the official formula, or for official unit, will be gram per mole. You can write G M O negative 1, MOL negative 1. Alright, so as we move along, then we can do a few calculation. Now you look at this, 1 mole of carbon, you have 12 gram. 2.5 mole of this would have 2.5 times 12. Okay, so the total mass, the total actual mass is 30 gram. Now let me ask you a simple question again. This one seems like a standard number, that's why we call them molar mass. Using relative atomic scale, molar mass, mass of 1 mole. Now this one is the number of mole. So I'll just put small n. And this one is the actual mass. 30 gram doesn't look like a standard number to me, but it is a actual mass, an actual mass. So now you combine these 3 formulas together, you realize that this times this, you get this. Alright, so may I write the formula as the actual mass equals to number of mole times the molar mass. Is this having similarity with this formula? Remember just now, in our previous study, this one is more about the amount, while this one is more about how heavy the substance is. Okay, but they use the same premise. because if you look at what I'm going to the short notes I'm putting, here is the actual mass. This is just a mole. This is a standard mass. Standard mass is always about 1 mole. 1 mole would have 12 gram for carbon. 1 mole would have 80 gram for bromine. This one is also actual number, and then this number of mole, and this one is Avogadro's constant. It's also some type of standard mass, standard number. Okay, this is standard mass, but this is standard number. So they bear similarity. So example calculation would be like this. Let's say I have 7.46 mole of sodium atoms. Okay, so what is the actual mass? What is the actual mass? So if I'm interested to get the actual mass, I can just put up the formula that I've learned. So that would be M, number of mole, time molar mass. So given the molar mass of sodium is 23 gram per mole, so what we do is we put 7.46 mole times 23 gram per mole. Okay, in physics or in science, they teach you that if the unit multiplication, you look at this one, mole times mole negative 1, you get no more unit. The final unit you're going to get is simply just gram. You saw the gram here. Alright? So 7.46 times 23, you will get 171.58. So that will be 171.58 gram. You get an actual gram of 171.58 gram. Alright?